Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into an 11th grade topic, half-angle identities. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Senpai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash the subscribe button, and let's get started. Now today we're going to be covering half-angle identities. However, the real MVP for today's video is going to be our double-angle identities that we covered in our previous video. Now, if you hadn't seen my previous video on double angle identities and you have no idea what they are, you can check it out right up here. However, we're not going to be looking at all the double angle identities. We're going to be focusing on just one, and that's the cosine double angle identity. So for your reference, I put it right up here for today's video. Now, you may be asking, why are we going to be using cosine's double angle identity for this video? Well, as you see, cosine has the most versatile double angle identity, and this is going to prove crucial when trying to recreate our half angle identities. So let's start with trying to find our cosine half angle identity. Now, if you had to guess which one of these cosine double angle identities would help us trying to find our cosine half angle identity? Well, if you said our first one, you would be wrong, because this has a lot going on. There's cosines and sines in there, and that's just a little bit too noisy. We want to find cosine's half angle identity, and we're trying to start with cosine's double angle identity. Which one do you think we're going to need then? If you said our second one, you would be correct, because this has a little bit of what we're looking for. Now, you might not necessarily see why automatically, but just wait and you'll see in just a moment. We're going to start with this second one here, and we're going to rewrite it as such. So we have our cosine of 2x equals 2 cosine squared x minus 1. Now, like we've been saying, we want to find cosine's half angle identity, half angle. So let's focus on the angles for these trig functions. We have a 2x and we have an x. Which one is half of the other? This x is half of the 2x. So we want to start there. Let's get this by itself. This is currently by itself. Let's get this by itself so we can have a half angle on its own on the other side of the equal sign. So let's get this by itself. So now we've gotten this by itself. Now let's square root both sides because we don't want squares in our identity. So let's square root both sides and see what we get. Now this is automatically on a dropout because we're going to be square rooting something that's squared. So that's just going to give us a cosine of x automatically. This is going to give us a plus or minus, and we're going to just rewrite it just to make things cleaner. Just rewrite it all over 2. Now technically you could stop here, but this doesn't really look half anglish because we have some double angles in here. So instead of writing it like this and leaving it like this, let's do a little bit of substitution. Let's say, for example, x is going to be y, let's choose another variable, over 2, just so we can get a half going on. So I'm going to rewrite all of this, substituting in our y over 2, and we're going to have cosine on the left this time, just so I can have an easy way of looking at it. Y over 2 equals, we're going to keep that plus or minus, we're going to put a big square root here, and it's going to be a cosine. When you plug in y over 2 for this, the 2's cancel out, which leaves you with just y plus 1 all over 2. So now we have cosine of y over 2 equals plus or minus the square root of cosine y plus 1 all over 2. This looks just like you would expect a half angle identity to look. We have a half angle here and we have a single angle here, really emphasizing the fact that this is a half angle identity. So now that we found our half angle identity for cosine, let's do the same thing for our sine. So now we're going to try to find our half angle identity for sine, except we're going to still use our double angle identity for cosine. And if you had to choose which one would you choose? Well, we know we're not going to do the first one, and we just did our second one, so our best bet is going to be our third one, and it has sine in it, so that It should be a good indicator of this is the one that we want. So let's start with that identity here. We have 1 minus 2 sine squared x. Now, just like the previous one, we're going to figure out where are we going to start. Which one do we solve for? We see a 2x and we see an x. Which one's the half? Well, x is half of this 2x. So let's get that by itself. Let's get whatever this is by itself. And of course, once again, this is our sine half angle identity. So this is a good indicator of where we're going to be starting. So getting sine by itself, we're going to get this. Now, I didn't emphasize this last time in our previous example, but I want to make sure I am mentioning it so you don't forget it. Whenever you find a square root of both sides, don't forget your plus or minus. This is crucial. You have to remember to put your plus or minus there. And just like we did for cosine, we're going to try to substitute this x for y, and we're going to say x is going to equal the same thing, y over 2. Technically, you could leave it like this. This is an identity, and technically this x is half of this 2x, but we want to make it look like a half angle identity. So let's substitute all our x's for y over 2 like we did previously, and I'll put sine on the other side. So now we have sine of y over 2 equals plus or minus the square root of 1 minus cosine of y all over 2. This is going to be our half angle identity for your sine. And I didn't mention this in the previous example either, and I don't want to be called out for not saying anything about it, but it really doesn't matter what your variable is. So we had an x up here, I've changed it to a y, but it really doesn't matter as long as this holds true. The main reason why I didn't want to finish with an x is because I didn't want you to think that this x is the same as this x here. You don't naturally just change this 2x or this x into half angles now. There's a step involved. I don't want you to think that you can just magically make them half angles. But this was just a transition from the double angle identity to the half angle identity. When you're just working with your half angle identity, this can be any variable you want. X, Y's, Z's, A, B, C's, it doesn't really matter. But now that we've covered cosine and sine, let's move on to our tangent half angle identity. Now, I know I said the MVP for this video is going to be our double angle for our cosine. However, we don't need that for our tangent. We use it for both sine and cosine, and that's more than enough. Because for tangent, we're going to be taking advantage of a different identity. Our basic identity of tangent equals sine over cosine. And in my previous examples, we found both the half angle for sine and the half angle for cosine. So we're going to just simply plug those in and see what we get. But before we begin, I want to warn you, tangent actually has a bunch of different identity phases, just like our cosine did for our double angle identities. But you'll see what I mean by that when we get there. Let's start by finding our most basic half angle identity for our tangent. So we're not going to need this because we're going to rewrite it. Tangent, making sure everything's consistent, and notice everything's in x's now, of x over 2. Our half angle is going to be sine of x over 2 over cosine of x over 2. Just like what we just wrote, tangent equals sine over cosine, and you make sure you keep that same angle the same. And we're going to rewrite this because we know what sine and cosine are. So just to give myself a little bit more space, I'm going to make this a little bit bigger than I did before. So we have a plus or minus 1 minus cosine of x all over 2 all over plus or minus 1 plus cosine of x all over 2. Now this may look very ugly to you, and that's fine. This can look very ugly, but we can simplify this a little bit because whenever we divide by a fraction, you're technically multiplying by the reciprocal. So we can rewrite this to be this, equals plus or minus the square root of 1 minus cosine of x over 2 times plus or minus the square root of 2 over 1 plus cosine of x. Now you can simplify this, and if you were, you would get this, plus or minus the square root of 1 minus cosine x all over 1 plus cosine x. And this is going to be our first half angle identity for tangent. Plus or minus the square root of 1 minus cosine of x over 1 plus cosine of x. But like I said, this is just one of many. There's technically 3 of them, and I'll show you how you can find both of them starting from here. So I'm going to rewrite this with this so we know where we're starting from. Now the 2 other identities will exploit getting rid of your radicals. We don't want the plus or minus this radical here, and there's a couple ways, 2 ways, of getting rid of that radical. The first and easiest is to multiply top and bottom by the denominator, because remember, when you have a fraction within your radical, you technically have this. So we're going to multiply top and bottom by this to begin with, our square root of 1 plus cosine of x. And when we do that, it looks like this. And we know that whenever we multiply a radical by itself, we're just going to be left with what's inside that radical. So let's rewrite the bottom as such. 1 plus cosine of x. And we also know that whenever you're multiplying 2 radicals, you can combine the radicals in this fashion. So we have one big radical, and we have 1 minus cosine x times 1 plus cosine x in that fashion. And notice we're multiplying 2 conjugates. So when we simplify this, we're going to get this. Now we aren't done yet. We can still do a little bit more here. So using some more identities that we know of, what's 1 minus cosine squared of x? Well, this is going to be plus or minus the square root of sine squared x all over 1 plus cosine x. And what happens when you square root a square? Well, you're going to just get sine of x over 1 plus cosine of x. This is going to be another half angle identity for tangent. Notice we started from here, our basic one, and just by exploiting trying to get rid of our radicals, we've gotten another completely different looking half angle identity. There's no more radicals and there's no more plus or minus. We just have sine of x over 1 plus cosine of x. But remember, I said there were 2 other half angle identities for your tangent, and you may have already realized how we're going to find that other one. Notice, when we multiply by the conjugate, we got rid of our radical. So that's another way of getting rid of our radical. So instead of multiplying top and bottom by the denominator, what if we did top and bottom by the conjugate? Now multiplying top and bottom by the conjugate is going to look like this. We have this 1 minus cosine x here, 1 minus cosine x right up here. We have the plus and minus still going on, and we already know what this is going to equal. We just did this when we found the previous version of tangent. This times this is going to result in just our sine of x. You don't have to repeat the work because we've already done it. But if you want to, sure, knock yourself out. And when we look at the top here, we have the radical of 1 minus cosine of x times the radical of 1 minus cosine of x. It seems like we're multiplying the same thing by itself, and that's always going to give us what's under the radical. So you can simply write this as 1 minus cosine of x. We drop the plus or minus because we don't need it anymore. So exploiting the work that we just did, we found our third way of writing our tangent half angle identity. 1 minus cosine x all over sine. So just for a quick recap, so you can see everything all at once, these are our 3 half angle identities for your tangent. We have plus or minus the square root of 1 minus cosine x over 1 plus cosine x. Make sure everything is under the radical. And we have for the second one, sine of x over 1 plus cosine of x, no radicals. And then we have our third one, 1 minus cosine of x all over sine of x. Once again, no radicals. So I hope you were able to follow along with today's video, and I hope you now know how you can derive your half angle identities. However, if you have any questions about what you saw today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel, but letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.